My name is Alexander Knopp, and this is Introduction to Mathematical Logic. In the previous video, we discussed how to formalize a notion of a statement in the propositional logic. In this video, we are going to give the first way to prove statements in the propositional logic. In order to understand what it means to prove something in the propositional logic, let's consider a kind of real-life example. Imagine that we know that Joe was a good boy, and we also know that if Joe is a good boy, then Santa gives Joe a present. It's easy to see that we may conclude from this that Santa will give a present to Joe. However, this one is not a propositional formula, and let's rewrite it as a propositional formula, both statements and the result. So let P denote that Joe is a good boy, and Q denote that Santa gives a present to Joe. In this case, the first statement is just P, and the second statement is if P then Q. So P implies Q. And the conclusion is Q. This argument is called a modus ponens. It's a middle-aged name for this argument. Let's try to understand why it is true. Because of this story with Joe, Santa, and their present, we feel that this argument should be correct. But what it means to be correct? It means that whenever these two propositional formulas are true, this propositional formula is also true. How can we check that it's true? We can brute force all the values of the variables P and Q and check that whenever this is true as well. So we have P, we have Q, and we have P implies Q. So P can be true and false. Q can be true and false as well. If both of them are true, then the implication is true. If Q is false but P is true, the implication is false. If P is false, it doesn't matter what is the value of Q, the implication is equal to true. We're interested in the case when P is true, so we're interested in these two rows. Among them, we need to choose the rows when P implies Q is true. So we're interested only in the first row. And you may notice that Q is true in this row. So whenever these two formulas are true, this is true as well. In other words, we prove that P and P implies Q implies Q is always true. And we call such a formula a tautology. Such an argument is also known as modus ponens. Let us consider another example. Imagine that we know that if x is greater than 2, then x squared is greater than 4. We may conclude that if x squared is not greater than 4, then x is not greater than 2. Okay, let's again rewrite it using the propositional formulas. So let P be a statement that x is greater than 2, and Q be a statement that x squared is greater than 4. So we know that P implies Q, and we may conclude not Q implies not P. We again have an argument which seems correct. Let's try to verify it again using the truth tables. So we have P, we have Q, we have P implies Q, and we also have not Q implies not P. So P can be true and false. Q can be true and false as well. If both of them are true, the implication is true. If this is true and this is false, the implication is false. Otherwise, it's true. Okay, what about this? If not Q is true, in other words, if Q is false, that this is true only when P is false as well. So in this case, it's true. In this case, Q is true, so the negation is false. So this is true. In this case, the negation of Q is true, and the negation of P is false, so it's false. And finally, in this case, the negations of both of them are false, so it's true. And you may notice that these two columns are the same, and it means that whenever this is true as well. In other words, we proved that P implies Q implies not Q implies not P is a tautology, and such an argument is called the contraposition argument. In this video, we gave a simple method to verify that a tautology is indeed a tautology, or to verify that some argument is correct. There are unfortunately two big problems with this method. One of them is if we have 10 variables, we have more than 1,000 rows, which is way too much. Another problem is that this method is not similar to the real proofs we use in mathematics. In the next video, we are going to discuss a method which is very similar to real proofs, and sometimes it's much shorter than just a brute force. If you have any questions, ask them in the comments. See you later.